Okay, today we're going to be looking at density and how to calculate the density of different objects and items. Density is mass divided by volume. Today, obviously, all of the mass we're going to be looking at, grams, and we're going to be looking at volume in cubic centimetres. Now clearly, to calculate the volume of a solid, this is a solid lump of aluminium that's a regular shape, is quite straightforward. We just measure the length, times it by the width and times it by the height. Calculated that earlier. It's 5 centimetres by 4 centimetres by 3 centimetres, which gives us a volume of 60 cubic centimetres. If I pop that on there, it will give us a reading of 161.53 grams. So with a crafty little bit of calculation, we should have 161.53 grams divided by 60 cubic centimetres equals 2.692 grams per cubic centimetre. Now, in ordinary circumstances, you'd be doing this experiment with several different metals and regular shaped items, and this just gives you an idea of the relative density of each of these different items. Gold, obviously, look, is particularly dense and might be part of the reason for its value. 19.3 grams per cubic centimetre, just for way of an example. Now that was fairly straightforward when we're just talking about a regular shaped item. What happens when we've got an irregular shaped item such as this stone? Well, we can calculate the mass easily enough. We've got 45.9 grams as the mass, 45.9. How do we calculate the volume of the irregular shape? Well, the best way of doing it, we've got here set up a displacement can, sometimes called a Eureka can. That's filled with water to the point that you can probably just see there is a little drop about to come out. Now, I literally filled that up earlier and allowed all of the spillage to make sure it's absolutely full to the brim. All of the spillage is collected in this beaker. Now, we carefully lower, so we don't want to cause any waves, we carefully lower our irregular shaped item into the water. Now this is going to give us a volume of the water displaced by that object. Sorry, I'm taking that out of the way a little bit for you. Now you can see the water just drips through, it doesn't pour out particularly. We're getting up to about 10 cubic centimetres there. And as soon as that's done, it will give us a figure. You do need to think, when you're doing this with different items, and again in ordinary circumstances you'd be using several different items in here, different irregularly shaped items. If you know it's going to displace an awful lot of water, something much larger would have displaced a lot more water, then we obviously would have needed a larger measuring cylinder. However, to be as accurate as we can, we probably want to go to the smallest size of measuring cylinder appropriate to what we're going to estimate our displacement to be. So you can see we're just about 16 now, slowing down nicely. It's just about stopped at, we'll call it 16.5 cubic centimetres. So again, quick calculation. We've got density equals mass over volume. The mass was 45.9 divided by the volume, 16.5 equals, that will give us a density of 2.78 grams per cubic centimetre. Okay. Now the final one is just to show you how we can calculate the density of a liquid. here we've got a sugar solution. It's actually glucose, and I've got a specific volume of it, which I know is 100 cubic centimetres. So what we're going to need to do here is calculate the mass of an empty beaker, which is 122.6 grams. Always remember to keep putting our bits and pieces on there. I'm going to pour the known volume of our liquid into there, make sure we don't miss any. Now we can calculate the mass of the liquid plus the beaker, 225.4. 225.4. So to calculate the mass of the liquid that we've got in there, we just simply have to subtract the two. I'll do it quickly on my calculator just to be sure I don't get anything wrong when we have to film again. So we've got 225.4 minus 122.6 equals 102.8. Now then, what we're going to need to do is use that as that's our mass of the liquid. We can put that onto our table. Density equals mass divided by the volume. We know the volume was 100. We now know that the mass is 102.8. So we can do another quick calculation. 102.8 divided by the volume 100 equals 1.028 grams per centimetre cubed. Now that is giving us the density of the liquid, but perhaps what we're interested in is just how much sugar is in there. We can work out how much it is because we know this has all been calculated beforehand. The density of water on its own is 1 gram per cubic centimetre. The reason why the weights were all set up in the first place along those lines is to make it easy so that we know what we're doing. So we can see that if we subtracted 1 from our 1.028, we know that our density of sugar in there, that solution is 0.028 grams per centimetre cubed. There we go. So that's just 3 different ways. You can calculate other densities, density of a gas and various other different things, but it just shows you that you can calculate density in a number of different ways. Thank you.